Hey guys, tonight we stand at the edge of everything you have ever known, under a sky that looks quiet and ordinary at first, as if it is only there to keep the dark in place. And yet above you the stars are hanging like patient little time capsules, each one sending a small, steady message across impossible distance. The air feels cooler out here. The world has finally lowered its voice. Before you get cozy, take a moment to like the video and subscribe, but only if you genuinely enjoy spending time here with me. And if you feel like it, post your location and your local time in the comments, because there is something oddly comforting about knowing where in the world you are listening from while we look so far beyond it. Let the world slow down for a moment. Let the fan murmur softly nearby, and let's slip into tonight's journey together. You begin with something simple because the universe is usually kind enough to start simple before it becomes strange. You look up, and the first feeling is not really science at all. It is recognition. Human beings have been doing this for a very long time, standing still under the night sky and feeling that quiet little mix of comfort and smallness. A roof, a field, a balcony, a patch of road outside a sleepy house. It does not matter much. The sky always seems larger than the place you are in, and somehow calmer too. At first, it can seem as though the universe has an edge in the same way a room has corners, or an ocean has a shoreline, or a blanket has a stitched seam where the fabric simply stops. That instinct is very natural. Your mind likes containers. It likes tables with edges, windows with frames, books with final pages. So when you hear the phrase edge of the universe, some part of you quietly prepares for a wall, a rim, a border post in space where the stars politely end and someone has forgotten to install more cosmos beyond it. The universe, with its usual graceful refusal to behave like household furniture, has other ideas. Still, that is part of what makes it so relaxing to think about at night. The edge of the universe is not a sharp thing waiting to startle you. It is more like a soft puzzle, a horizon that keeps shifting as your understanding grows, a question that becomes more beautiful the closer you get to it. You can start with the oldest truth your eyes already know. The sky is not immediate. Even the moon, which feels so close and familiar that it almost belongs to your neighborhood, is far enough away that its light takes a little over a second to reach you. The sun, bright and shameless as always, is about 8 light minutes away. So when sunlight lands on your skin, it is already a tiny bit old. Not ancient, just fashionably late. Then you move farther out. The stars you can see with your own eyes at night are so distant that their light often began its trip years, decades, or centuries ago. Some of the brighter ones are practically local, by cosmic standards, which is a very funny sentence when local still means trillions of miles. Others are so far away that the version of them you see belongs to another time entirely. The night sky is full of delayed arrivals, and somehow it never feels rushed. Everything gets here when it gets here. That is one of the gentlest facts in astronomy. Looking out into space also means looking back in time. You do not need a time machine. You just need light, distance, and a clear night. The universe keeps its history in transit. It does not hand you the present all at once. It gives you old glimmers, patient evidence, tiny glowing postcards sent across the dark. And that means the search for the edge of the universe is also a search for the oldest things you can possibly see. You can imagine yourself lifting gently away from Earth for a moment, not in any dramatic way, nothing noisy or cinematic, just a slow and impossible float upward, leaving behind cities and clouds and oceans until the planet becomes that familiar blue curve, beautiful and a little absurd in its confidence. From farther out, Earth has no visible borders at all. No fences, no highlighted regions, no warning label saying you are here. Just weather, light, water, and a thin atmosphere glowing softly like a held breath. That alone is calming. So much of what feels loud and urgent down here becomes invisible almost immediately. And above that small blue world is a universe that also does not show you its seams. When astronomers talk about distance, they often use the light year, which sounds dramatic, but it is really just a practical way of dealing with the fact that normal units stop being useful very quickly. If someone tried to tell you how far away a galaxy was in miles or kilometers, you would age slightly before they finished. A light year is the distance light travels in 1 year, and since light moves at about 300,000 kilometers every second, a single light year is already enormous. So enormous that your mind does what minds do best at bedtime and quietly turns it into a feeling instead of a number. Very far, gracefully far, far enough that urgency no longer makes sense. Keep that feeling nearby because it matters. The universe you can observe is shaped by light's travel time. That means there is a limit to how much of the cosmos you can see, not because there is necessarily a hard edge out there, but because the universe has existed for a finite amount of time, and light itself only moves so fast. The cosmos is old, incredibly old, about 13.8 billion years old according to the best measurements we have, but not infinitely old. So there are places whose light has had time to reach you, and places whose light has not. That simple fact creates one of the most soothingly strange ideas in all of science. The edge you are searching for may not be an edge in space the way a cliff has an edge. It may be an edge in visibility, an edge in what can be known by sight, a horizon made of time. And horizons are familiar. You have seen them all your life. Standing by the sea, you never assume the world ends at the line where the water meets the sky. You understand, even half asleep, that the horizon marks the limit of what you can see from where you are. The observable universe works a bit like that, only on a scale so vast that language has to walk slowly to keep up. From where you are, in this quiet corner of cosmic history, there is a maximum distance from which light has had enough time to arrive since the universe began. Beyond that, there may be more stars, more galaxies, more darkness, more structure, more beauty. Science does not rule that out at all. In fact, many models suggest there is far more beyond what you can observe. You simply cannot see it because its light has not reached you yet, and may never reach you depending on how space itself behaves. Which is rude, honestly, but also beautiful. That is the first deep calm of the universe's edge. It is not a crash barrier. It is not a final brick wall. It is a limit shaped by patience. And patience is everywhere out there. Galaxies turn slowly. Light travels steadily. Gravity gathers matter without any need to announce itself. Even the stars seem to understand the mood, burning for millions or billions of years as if they have nowhere urgent to be. The universe does not rush to explain itself. It gives you clues in long, quiet intervals. It lets you learn by degrees. It trusts you to stay with it. So you stay. You keep floating a little farther in your mind, carrying Earth with you as a memory, carrying that porchlight feeling from the beginning, because the most comforting part of this whole subject is that the grandest truths still begin with something intimate. One person, one night, one sky, one curious glance upward. Soon, that glance will carry you to the oldest light of all, a faint glow left over from the early universe itself, still spread across the sky like the afterwarmth of creation. That light will bring you closer to the edge than almost anything your eyes can imagine. But for the moment, it is enough just to hold the horizon gently in your thoughts, and to notice how the universe becomes less frightening when you stop expecting it to end like a room and start letting it open like a landscape. You keep that horizon in mind, that soft, invisible boundary drawn not by a wall but by waiting. And from there, the next quiet truth arrives almost politely. Everything you see in space comes to you on a delay. Nothing in the night sky appears exactly as it is in this instant. It appears as it was when the light left it, and that means the universe is never really presenting itself live. It is offering a calm replay, one glowing moment at a time. That can sound abstract at first until you let it become physical. Light is not just brightness, it is travel. It moves fast enough to circle Earth more than 7 times in a single second, which is already far beyond anything your everyday intuition is built to handle. And yet the universe is so spacious that even light, moving with all that confidence, still needs time. A lot of time. More time than seems fair, really. If you flick on a lamp in a dark room, the light reaches the wall so quickly that your senses treat it as immediate. The world trains you to think of light as something that simply appears. Space gently corrects that idea. Out there, light is not instant. It is a traveler crossing enormous silence, carrying the shape and color of distant things toward you with patient determination. You already know the moon's light takes a little over a second to arrive. That tiny pause is almost sweet once you notice it. It means the moonlight on a rooftop, or on a road, or across your window has crossed a real distance to find you. Sunlight takes about 8 minutes. So the warm afternoon you remember, the bright stripe across a floor, the gold on someone's face, all of that is slightly delayed. The sun you see is the sun from a few minutes ago, which is such a modest delay that daily life forgives it completely. But move outward, and the delays become part of the story. The nearest star beyond the sun is Proxima Centauri, and its light takes a little more than 4 years to reach Earth. When you look in that direction, you are not seeing that star as it is tonight. You are seeing it as it was more than 4 years ago, back when your own life was arranged differently, when ordinary days had other sounds, other worries, other weather. A star can shine into your eyes from the past while you stand in the present holding a cup of tea or adjusting a blanket. Space has no issue with this arrangement. It thinks it is completely normal. And once you begin noticing that, the whole sky changes character. The constellations people have used for centuries start to feel less like decorations and more like archives. Bright stars in the same pattern may not truly belong together in any close, local sense. They only line up from your angle here on Earth, like distant streetlights appearing neat from one corner of town. Some may be dozens of light years away. Others may be hundreds. The pattern is real to your eye, but the distances inside it are uneven and grand. Even the familiar sky is deeper than it looks. You can picture this in a softer way. Imagine every star as a singer in a vast dark hall, and each voice takes a different amount of time to reach your seat. Some arrive almost immediately. Some drift in late, still clear, still beautiful. What you hear is not one simultaneous performance but a layered arrival, a chorus assembled by distance. The night sky works a little like that. It reaches you in staggered notes. This is why astronomers can read history by looking outward. A telescope is not only a tool for seeing far away, it is a tool for seeing far back. Every extra bit of distance is also extra time. When you observe a galaxy 10 million light years away, you see it as it was 10 million years ago. When you observe one a billion light years away, you see a version of the universe from long before humans existed, long before Earth looked the way it does tonight, long before almost anything familiar had taken its current form. And still the light arrives quietly. That is the soothing part people do not always mention first. The universe could have arranged itself in a much more chaotic style. Instead, it lets information travel in a clean and reliable way. Light crosses the dark. It follows rules. It keeps time. It makes distance understandable. Without light's steady speed, the cosmos would feel far more slippery and far less knowable. Instead, even its remoteness comes with structure. You can trust the delay. You can build knowledge from it. You can also feel very, very small in the presence of it, but in a pleasant way, like standing in a cathedral after everyone else has gone home. A light year, despite the dramatic name, is just a distance. It is how far light travels in 1 year, and that turns out to be about 9.46 trillion kilometers. Your mind does not really want to hold that number, and honestly it should not have to. Numbers that large stop behaving like feelings, so it helps to translate them into something gentler. A light year is the distance a beam of light covers while Earth goes once around the sun, and the seasons complete a full cycle. Spring to spring, winter to winter, all that time the light keeps moving, and after a whole year of that motion, it has only traveled 1 light year. Many stars are dozens or hundreds of light years away. The Milky Way galaxy is around 100,000 light years across. So if a beam of light began crossing our galaxy from one side to the other, it would still be traveling long after every empire in human history had come and gone, long after languages changed, coastlines shifted, forests vanished and returned, long after all the little urgent things of one century gave way to the little urgent things of the next. That scale does something interesting to your thoughts. It loosens them. It makes hurry look less important. The universe keeps everything on a larger clock. And the farther outward you go, the stranger that clock becomes. Some galaxies are so distant that the light entering a telescope tonight began its journey before Earth had complex animals. Some began when our planet was still very young. In those cases, you are not just looking at a faraway object. You are looking into an older chapter of cosmic history, catching the universe in a more youthful mood. This is one reason the phrase edge of the universe becomes so slippery. You might imagine traveling outward until you reach the last place, the final region, the outermost border. But what you actually reach, in terms of observation, is a limit set by light and time. There is only so far back the visible record can go. There is only so much of the cosmic story whose light has had time to enter the theater. And even within that record, light itself can arrive altered. As it crosses expanding space, the light from very distant galaxies gets stretched. Its wavelength grows longer. Visible light can shift toward red, then farther beyond red into infrared and even radio wavelengths. This effect is called redshift, and it is one of the universe's gentlest clues that space is not sitting still. The light has been traveling for so long through a changing cosmos that its very color tells part of the journey. It is as if distance leaves a soft signature on the beam itself. That detail matters more than it first appears to. It means the universe is not simply a static backdrop where light moves through fixed emptiness. The stage itself changes while the message is in transit. Space expands. Distances grow. Ancient light arrives stretched and softened by the long trip. If the cosmos were a letter, it would reach your door with the paper slightly weathered, edges bent by time, still readable, still precious, carrying signs of the road. Remember that image, because it will matter soon. It also helps explain why astronomers build instruments that can detect far more than ordinary visible light. Your eyes are lovely, but they are not designed for the deepest history. To catch the oldest, most stretched light, you need detectors sensitive to the quieter parts of the spectrum. Infrared telescopes, radio telescopes, all these careful machines are ways of extending human sight into wavelengths that ancient distance prefers. So even when the universe seems dark, it is often only dark to you in the narrow sense. It may still be whispering in other forms of light, low and steady, waiting for the right instrument to listen. And maybe that is one of the nicest thoughts to carry forward tonight. Space is not empty in the simple way it first appears. It is full of messages crossing time, full of arrivals still underway, full of old light entering the present with almost absurd patience. Every star overhead is a delayed hello. Every galaxy is a memory made visible. Every deeper glance turns distance into history. Soon that will bring you to a much older glow, a light so ancient it does not come from stars at all, but from a time before stars had properly taken over the sky. For now, though, it is enough to rest with this simple, beautiful rule. The universe becomes visible only because light keeps going, slowly if you are the universe, astonishingly fast if you are anything else, and always with the calm persistence of something that has all the time it could ever need. All of that delayed light, all of those old arrivals crossing the dark with such patient determination, leads you toward a very calm and slightly slippery idea. There is a limit to what you can see, and that limit is not the end of everything. It is only the end of what light has had time to show you. That difference is quiet, but it changes the whole feeling of the universe. When people first hear about the edge of the universe, they often picture a place, a distant boundary somewhere out there, waiting like the last fence at the end of a field. A rim, a border, some enormous cosmic version of a sign that says you have reached the final visible county, and the stars will not be continuing service beyond this point. The real picture is softer than that. It is less like reaching a wall and more like standing inside a circle of visibility that time has drawn around you. The name astronomers use for that circle is the observable universe. It is everything whose light, or other signals, has had enough time to reach you since the universe became transparent enough for light to travel freely. That last part matters, and we will come back to it soon, because the early universe was not always the kind of place where light could move through space the way it does now. For the moment, it is enough to hold one simple image in your mind. You are not looking out at all that exists. You are looking out at all that has had time to become visible from here. And from here, the view is astonishingly large. The universe is about 13.8 billion years old. At first, that sounds like it should make the visible limit about 13.8 billion light-years away, since light travels 1 light-year in 1 year, and that would be a perfectly reasonable guess from a human brain doing its honest best at bedtime. The universe, still refusing to behave like a neat classroom example, adds one more detail. While the light has been traveling, space itself has been expanding. The galaxies that sent some of the oldest light you can observe are no longer where they were when that light began its journey. They are much farther away now. So the observable universe is larger than the simple age-time-speed calculation suggests. The most distant matter you can in principle observe today is roughly 46 billion light-years away in every direction. That means the observable universe has a diameter of about 93 billion light-years. Even said gently, those numbers feel large enough to make language sit down for a minute. It helps to turn the number into a shape instead of a figure. Imagine a vast sphere centered on your present location, not because you are special in any dramatic cosmic way, but because every observer naturally finds themselves at the center of what they can observe. Your horizon always surrounds you. That is true standing in a field, and it is true standing on a planet inside a galaxy, inside a universe that seems to have no interest in making things small for your convenience. That can sound strangely personal at first, a universe centered on you, very flattering, slightly suspicious, but it is only a matter of perspective. If someone lived in a galaxy billions of light years away, they would also see themselves at the center of their own observable sphere. They would have their own horizon, their own limit, their own ancient light still arriving. Every point gets to feel central to its own view, which is honestly one of the more diplomatic choices the cosmos has made. This is where the word edge needs to be handled with care. The edge of the observable universe is not a physical surface. There is no shell there, no cold glass, no curtain rustling in the distance. It is a boundary in the story your eyes are allowed to read. Beyond it, there may be more universe, perhaps vastly more. The light from those regions simply has not reached you. In some cases, because of cosmic expansion, it never will. That last detail has a hush to it, a permanent hush. There are places so far away that even though they exist within the larger cosmos, the expansion of space keeps stretching the distance between you and them so effectively that their newer light cannot make progress toward you. The old light may already be on its way from earlier times, and that is what you detect, but the later chapters of those remote places can slip beyond reach. It is as if the universe hands you the first pages of a distant story, then slowly pulls the remaining pages away across a widening room. Still, the horizon itself is not harsh. It is more like mist at the edge of a lake in early morning. A limit, yes, but not an aggressive one. A natural consequence of living in a universe with a history. You can feel this more clearly if you think about ordinary horizons again. When you stand at the seashore, the curve of Earth and the limits of sight give you a line in the distance where the water seems to meet the sky. That line is real as a visual boundary, but it is not the end of the ocean. Someone standing far away on another coast has a different horizon, equally real, equally local. The observable universe works in a similar spirit. Your cosmic horizon is real. It defines the farthest light you can receive, but it does not claim to be the end of existence itself. That distinction is one of the gentlest gifts science can offer. It lets mystery stay in the room without turning it into fear. Because once you understand that the edge is really a horizon, the universe becomes less like a trap and more like a landscape. Large, open, unfinished from your point of view, but not hostile. There is no sense of crashing into the final barrier. There is only the quiet recognition that visibility has limits. Your window is immense, but it is still a window. And even that window is not static in the everyday sense. As time passes, light from farther regions has more opportunity to arrive. The observable universe changes. Its history deepens. The horizon is shaped by time moving forward, by photons continuing their long journeys, by space continuing its slow, majestic rearrangement. So the cosmos is not just sitting there waiting to be looked at. It is participating. It is unfolding its visibility little by little, which feels almost courteous. Keep that image nearby, because it matters soon. The farthest visible light is not coming from stars or galaxies in the ordinary, familiar way. It comes from something even older, a glow left over from a young universe that had not yet settled into the structure you know. That ancient light marks one of the deepest horizons of all, and it gives the sky a hidden softness you would never guess just by looking up casually from a driveway or a quiet street. Before you get there, it helps to stay for one more moment with this beautiful fact. The edge you seek is partly made by time, partly by light, partly by expansion, and partly by your own position inside the cosmos. That sounds complicated when compressed into a sentence, but it feels simple when you let it breathe. You see what has had time to arrive. You do not see what has not. The line between those two things is your cosmic horizon. And a horizon, by its nature, is something you live with rather than solve. You do not need to conquer it. You only need to notice it. It sits at the far end of vision, quietly reminding you that reality is always larger than the portion currently lit. That is not a bad thought to fall deeper into. It means the darkness is not empty. It may simply be waiting its turn. It means the sky is not withholding itself out of cruelty. It is following the rules of distance with steady honesty. It means your small life on this small world is wrapped inside a sphere of ancient signals, all arriving from different ages, all meeting here in this brief present moment where you can look up and understand just enough to feel wonder without needing control. Soon, the oldest light will appear, faint and everywhere, and the horizon will stop being an idea and start becoming a glow. That glow does appear, and when it does, it changes the mood of the whole journey. You have spent this long, quiet drift thinking about stars, galaxies, distance, and horizons, and all of that has been leading toward a light that does not belong to any star at all. It belongs to a much earlier universe, a younger one, a stranger one, a universe that had not yet arranged itself into graceful spiral galaxies or familiar constellations, or the soft silver light on the edge of a cloud. It is the oldest light you can truly see, even if your eyes alone cannot catch it. And it is still here, spread across the sky like a whisper that never quite faded. This light is called the cosmic microwave background, which is a very practical name for something that feels almost mythic. It is often shortened to the CMB, perhaps because the full name sounds a little formal for a glow that has been drifting through the universe for nearly all of cosmic history. But the thing itself is beautiful. It is the afterglow of the early universe, the faint remnant of a time when everything was much hotter, much denser, and much more closely packed than it is tonight. To picture it gently, imagine the universe in its first long stretch as a bright fog. Not fog in the ordinary earthly sense, not mist over a road or steam on a mirror, but a thick, hot haze of particles and light all jostling together so densely that light could not travel very far without bumping into something. Photons, the particles of light, were constantly scattered. They were trying their best, but the early universe was crowded in a way that made straight travel impossible. That means there was a time when the universe was glowing but not transparent. Light existed, certainly, in enormous abundance, yet it could not move freely across long distances. It was trapped in that hot, bright plasma, bouncing, scattering, turning the whole cosmos into something more like a luminous interior than an open view. Then, as the universe expanded, it also cooled. This is one of those wonderfully calm facts in cosmology. Expansion and cooling go together, almost like a room becoming quieter as people slowly leave it. The universe made more space, and in doing so, it lowered the intensity of its own early chaos. After about 380,000 years, which sounds like a long time until you place it beside 13.8 billion years, and watch it become a very early morning indeed, things had cooled enough for electrons and protons to combine and form neutral atoms, mostly hydrogen and helium. That small shift changed everything. Once those charged particles settled into atoms, light no longer scattered around so constantly. Suddenly, the universe became transparent. Photons that had been trapped in that bright early fog were finally able to travel freely, and many of those very photons are still traveling. Some of them are reaching us even now, stretched and cooled by the expansion of space, arriving not as visible light but as microwaves. That is the cosmic microwave background. So when astronomers map the CMB, they are not simply observing some distant object. They are seeing the oldest baby picture of the universe that light allows. It is a portrait from a time before stars had fully taken over the sky, before galaxies had assembled into their mature forms, before planets and oceans and late-night listeners existed to wonder about any of it. It is the universe in a simpler mood. Hotter, yes. Brighter, yes. But also more even, more smoothly spread, as if everything had not yet decided where it wanted to gather. And the remarkable thing is how uniform that glow is. When you look at the CMB across the sky, it is almost the same in every direction. Very nearly the same temperature everywhere, about 2.7 degrees above absolute zero today, which is to say astonishingly cold, only because the light has spent billions of years being stretched by cosmic expansion. But it is not perfectly uniform. There are tiny variations, tiny warm and cool patches, differences so small they are almost comically delicate. And those little differences matter enormously. Those slight irregularities were the seeds of everything that came later. In the early universe, Regions that were just a little denser than average had a slightly stronger gravitational pull. Over immense spans of time, those regions gathered more matter. They grew. They thickened. They eventually helped form the grand structure of the cosmos, the galaxies and clusters and filaments that fill space today. So hidden inside that nearly smooth afterglow is the beginning of all later complexity. The stars above you, the Milky Way, Earth, your own presence in this quiet moment, all of it traces back in some deep and patient way to those tiny ripples in the early light. That is one of the most relaxing facts about the universe because it makes grandeur feel gentle. The largest things grew from the smallest differences, not from a cosmic shout, but from minute quiet unevenness, from almost nothing at all. A slight excess here, a slight thinness there, gravity taking its time, structure forming with no need to hurry. The CMB fills the whole sky. That is another lovely part. It is not located in one special direction. It surrounds you. If your eyes could see microwaves, and if human biology had made some fairly unusual design choices, the sky would look softly luminous everywhere with this ancient glow. Day and night would carry traces of it. The whole universe would feel faintly backlit by its own memory. That thought is worth keeping nearby. You are not just looking out into a cold darkness interrupted by stars. You are living inside a cosmos still carrying the warmth of its earliest visible moment, cooled almost to nothing, but not completely. The afterglow remains. It was discovered by accident in the 20th century, which feels exactly right somehow. Two radio astronomers, Arno Penzias and Robert Wilson, were trying to understand an annoying, persistent noise in their antenna. It seemed to come from every direction. They checked equipment. They checked the sky. They even dealt with pigeons, and the less glamorous evidence pigeons tend to leave behind. The noise remained. What they had stumbled upon was not a technical nuisance, but the quiet relic radiation of the young universe. There is something deeply charming about that. Humanity found one of the most profound pieces of cosmic evidence, partly because the universe would not stop humming in the background. And it hums so softly. Measurements from later missions mapped the CMB in great detail, showing those tiny temperature variations across the sky with extraordinary precision. These maps are among the most important images in modern cosmology, though they do not look dramatic in the usual way. No blazing nebulae, no elegant spirals, just a mottled field of color representing minute temperature differences in ancient light. Yet from those tiny patterns, scientists can infer a great deal about the age, composition, and large-scale geometry of the universe. It is a reminder that some of the deepest truths arrive quietly, wrapped in subtlety. The CMB also marks a kind of visual horizon. You cannot see ordinary light from farther back than that, because before that time the universe was opaque. So in a very real sense, this afterglow is one of the deepest edges of visible history. Beyond it lie earlier stages of the universe, but not in a way light can directly show us. The CMB is like a softly glowing curtain, not a barrier in space, but a limit in visibility. Beyond it, the universe existed, certainly. It was already busy becoming itself. But the light from that earlier era cannot reach you in the same open way, because the cosmos had not yet become transparent enough to let it travel freely. So the search for the edge brings you here, to a sky filled with ancient baby light, to a cosmic memory field still murmuring all around you. And there is something deeply calming in realizing that the farthest visible thing is not a jagged cliff or a violent frontier. It is an afterglow, a leftover warmth, a faint and nearly uniform hush from the universe's youth. Remember that softness, because it matters soon. The next strange beauty waiting ahead is this. While that ancient light was traveling, the universe itself kept expanding, stretching the distances between galaxies, lengthening the light, quietly remaking the scale of everything. That ancient glow has been stretched for almost the whole history of the universe, and the stretching matters. It means the cosmos is not only full of distant things, it is full of changing distance. Space itself has been quietly growing, almost absurdly patiently, while light keeps crossing it. Once you settle into that idea, the universe feels less like a frozen stage set and more like a living landscape that has been slowly opening its arms for billions of years. This can be one of the strangest facts in astronomy when you first hear it, mostly because everyday life gives you almost no practice for it. In ordinary experience, when two things get farther apart, you imagine motion through space. A car drives away. A boat drifts from shore. A bird disappears into the sky with suspicious confidence. Distance changes because something moves across a background that stays where it is. On cosmic scales, the background itself participates. Galaxies are often described as moving away from one another because the universe is expanding, and that sentence is true, though it hides the best part. The space between large collections of galaxies gradually stretches. Over immense spans of time, that stretch adds up. Light traveling through the universe gets carried along inside a cosmos whose scale is changing while the trip is still in progress. That is why very distant light arrives redshifted, softened, lengthened, as if the universe has gently pulled on the light until its waves become wider and calmer. You can picture it with a simple image, one people often use because it behaves nicely at bedtime. Imagine raisins in a loaf of bread as the dough rises. Each raisin sees the others getting farther away, even though the key change is really happening in the dough between them. Or imagine tiny dots on the surface of a balloon as it slowly inflates. Each dot notices all the other dots drifting away. No single dot needs to be the center of the expansion across the surface itself. The space available is increasing. These images are helpful as long as you keep them soft around the edges. The universe is not literally a loaf, which would raise troubling questions about cosmic butter. It is not exactly a balloon either, but both pictures capture the gentlest part of the idea. Distance can grow because the framework of distance grows. This is why galaxies that are very far away tend to show more redshift. The farther the light has traveled, the more expansion it has experienced along the way. Edwin Hubble and others helped reveal this pattern in the 20th century, showing that distant galaxies are generally receding faster from us than nearby ones. That does not mean Earth occupies some grand throne at the center of everything. It means that in an expanding universe, each observer sees a similar pattern. From almost any galaxy, other distant galaxies would appear to be drawing away. The whole fabric is scaling up. There is something wonderfully fair about that. The universe does not hand one place the privileged view. It gives each location its own horizon, its own history of arrivals, its own expanding web of distance. And the expansion is slow enough locally that daily life ignores it completely. Your house is not expanding. Your body is not expanding. The Earth is not being quietly stretched like old bread dough while you sleep. Objects held together by stronger forces do not simply participate in cosmic expansion in the same loose way. Gravity, electromagnetism, and the other binding influences of nature keep local systems intact. The solar system stays together. The Milky Way stays together. Even the local group of nearby galaxies, including the Milky Way and Andromeda, is bound strongly enough that these galaxies are not being carried apart by cosmic expansion. In fact, Andromeda is moving toward us, which is a little dramatic of it, though still on a very leisurely timescale. So expansion becomes most visible across the enormous gaps between large cosmic structures, where gravity has not tied everything into one close, lasting arrangement. Out there, across the great dark between clusters and superclusters, Space has room to do its quiet stretching. And it truly is quiet. That is one of the most comforting parts. The universe does not expand with the mood of an explosion still ringing out. People sometimes imagine the Big Bang as matter blasting outward into empty space, like debris from some impossible detonation. The deeper picture is calmer and stranger. The early universe was not matter rushing into a pre-existing emptiness. Space itself was involved from the start, expanding everywhere. There is no central point in ordinary space you can fly back to and declare the official location where it all happened. The expansion is woven into the geometry of the cosmos itself. That softens the idea of an edge even more. If the universe is expanding everywhere, then you do not expect a neat outer boundary the way you might expect the edge of a puddle or the wall of a room. You expect horizons created by time, light, and geometry. You expect large-scale patterns. You expect the sky to reveal motion through redshift and ancient glow rather than through some final visible rim. You can almost feel this in the light from the cosmic microwave background. That afterglow began as far more energetic radiation in the hot young universe. Over billions of years, cosmic expansion stretched those wavelengths into microwaves, cooling the visible signature of that old light down to its present faint hush. The universe did not switch the light off. It thinned and lengthened it. It gave the glow more room to breathe. There is a certain kindness in that process. Things do not simply vanish. They fade by rule. They change by pattern. The cosmos keeps its promises with elegant consistency. Expansion also means the observable universe is larger than your first intuition wants it to be. Light has been traveling for 13.8 billion years, yes, but the space it traveled through did not remain fixed during that time. The destinations kept drifting farther away. So the most distant matter whose ancient light reaches us today is much farther than 13.8 billion light-years in present-day distance. That is how you arrive at the vast scale mentioned earlier, with a radius of roughly 46 billion light-years for the observable universe, large enough to make a human calendar feel very decorative. And yet even a scale like that is still a visible portion, a horizon, a bubble of knowable light inside a possibly much greater whole. There is one more calm detail tucked inside expansion that is worth holding onto. Because every distant galaxy appears to recede, the night sky carries a record of motion that is collective rather than personal. The universe is not moving away from you because of anything you did. It is expanding according to deep shared structure. That may sound obvious, but it has a quiet emotional effect. The cosmos is not reacting. It is unfolding. You can rest with that. You can picture galaxies suspended in a dark, immense web, each with its own billions of stars, each separated by gulfs so wide that even light spends ages crossing them, while the space between those islands slowly stretches on top of that. No sound, no urgency, just scale increasing with almost unreasonable patience, a kind of grandeur built from steadiness rather than force. Remember that steadiness because it matters soon. Expansion does more than create distance. It also creates limits. Some regions are so remote that their light can no longer fully catch up with the changing space between you and them. The universe remains visible, but only to a point, and beyond that point the dark is not empty at all. It is simply too far away, too stretched, too gently withdrawn into silence. That gentle withdrawal into silence is where the universe becomes especially beautiful. You have already felt how light takes time, how the observable universe forms a horizon, how ancient radiation still glows softly around you, and how expansion stretches the scale of everything. From here, one of the most delicate ideas in cosmology begins to settle into view. There are regions of the universe so distant that, from where you are, their light can never fully make its way here. Not because the light is weak, not because space is blocked, simply because the universe keeps opening faster than that light can close the gap. It is a strange thought at first, and perhaps a slightly rude one. The cosmos contains places that are not hidden behind curtains or walls, yet they remain beyond your future sight all the same. Their existence is not especially dramatic. They are just too far away, and the stage beneath the journey keeps stretching. This is where it helps to be very gentle with the language. People sometimes hear this and imagine galaxies speeding through space faster than light in some rebellious act of cosmic rule breaking. But the rule about nothing moving through space faster than light is still perfectly safe here. The important shift is that space itself can expand. Over large enough distances, that expansion can increase the separation between two regions so effectively that a beam of light, though always moving locally at the speed of light, still cannot win the long game. You can picture it in a sleepy, harmless way. Imagine walking along one of those moving airport walkways, except this one stretches longer as you walk. If it lengthens slowly, you still reach the far end. If it lengthens quickly enough, you make progress but never quite gain what you hope to gain. On cosmic scales, something like that happens with light. It always does what light does. It travels faithfully, locally, steadily. But the space between here and there can grow so much during the trip that the destination slips farther away faster than the message can truly close in. That is one of the reasons cosmology feels less like architecture and more like weather. The distances are not fixed lines on a map. They evolve, they breathe, they change their meaning over time. Because of this, astronomers talk about cosmic horizons in more than one sense. There is the observable universe, which marks the farthest regions whose old light has had time to reach you so far. And there is also a deeper limit, sometimes described through the idea of an event horizon in cosmology, a boundary related to what can ever influence you in the future. Some very distant galaxies may be visible to you today only because the light you receive left them long ago, when they were effectively closer in the cosmic sense. But as expansion continues, newer light from them may never arrive. You catch an early chapter of their story, while the later pages drift permanently out of reach. That thought has a certain tenderness to it. The universe lets you glimpse some remote things only in youth, only in earlier time, only before the widening became too great. You get a soft, ancient postcard, and then the address recedes into a silence no future telescope can undo. It sounds sad for a moment, but then it becomes peaceful. Limits like this are not failures. They are part of the texture of reality. The universe is not withholding itself out of coldness. It is simply vast and dynamic and governed by rules that remain astonishingly calm even when the consequences become immense. This is also where dark energy enters the room, quietly as usual. Dark energy is the name given to whatever is driving the accelerated expansion of the universe. That phrase can sound more dramatic than the mood actually feels. Accelerated expansion does not mean the cosmos is suddenly lunging in some wild new direction. It means that over large scales, the expansion is not merely continuing. It is increasing in its effect. Galaxies that are not gravitationally bound to us are, on average, receding in a way that reflects this long-term acceleration. And dark energy, at least for now, remains one of the great soft mysteries of modern science. No one has fully wrapped it up with a neat ribbon. The best current model suggests that about 2/3 of the universe's total energy content behaves in this dark energy-like way. You cannot see it directly glowing in the sky. You do not pass it on a road trip. It does not announce itself with a dramatic soundtrack. You infer it from the large-scale behavior of the cosmos, from how distant supernovae and the overall expansion pattern reveal a universe whose growth is speeding up. It is an invisible influence written into the grand geometry of everything. There is something very restful about that invisibility. The universe is shaped by forces and ingredients you do not personally need to control in order to belong here. Reality keeps functioning long before it is fully understood. In fact, that is one of its most reliable habits. Because of accelerated expansion, the cosmic future is a future of increasing separation. Distant galaxies beyond our local gravitational neighborhood will, over unimaginably long timescales, fade farther and farther away. Their light will become more redshifted, more stretched, dimmer, gentler, until some of them slip beyond practical and then fundamental reach. If some far future astronomers existed in the deep ages to come, they might see a much lonelier sky than the one above you now. Many of the external galaxies visible to us today would no longer be observable to them. The universe would appear smaller in visible content, even if the larger reality remained vast beyond measure. That is such a hauntingly quiet detail that it almost feels fictional, but it follows naturally from the rules you have been carrying with you all night. Light takes time, space expands, expansion accelerates, horizons are not static. And yet none of this makes the universe feel cruel. Oddly enough, it makes it feel more graceful. There is no violence in the way distance grows, no sound, no tearing, just a slow, dignified retreat of the farthest things, as if the cosmos has no interest in crowding your window more than necessary. You can take comfort in the scale of the present moment because of that. You happen to live in an era when the universe is still richly visible. The sky still contains evidence from many ages. The cosmic microwave background still wraps around you. Distant galaxies still send their old light. The great web of structure can still be traced across the dark by patient observation. You are living in a good time for seeing. That may be one of the most quietly moving facts in astronomy. Out of all the long stretches of cosmic history, there is a period in which observers like you can discover both the local beauty of stars and the large-scale truth of an expanding universe. You can still detect the baby glow of the cosmos. You can still watch galaxies recede. You can still infer that there are regions beyond what can ever reach you. The universe, for a while, is readable in a particularly elegant way. Keep that idea close because it matters soon. Once you accept that some things are beyond future contact, the question naturally softens into another one. If there is no final visible rim and no reachable outer wall, what kind of shape is this whole thing allowed to have? What does it even mean to ask whether the universe has an edge at all? What kind of shape is this whole thing allowed to have? That question sounds simple for about 3 seconds, and then the mind begins to notice how deeply it has been trained by ordinary objects. A room has walls, a table has edges, a page ends, a road bends through a place that already exists around it. You grow up inside bounded things, so it feels natural to ask where the universe stops. But the deeper you go into cosmology, the more gently that question loosens in your hands. The universe may not stop in the way your instincts expect. It may have no rim, no outer fence, no final ledge where reality awkwardly runs out of material. It may simply have shape. And shape on cosmic scales is a quieter idea than edge. You can start with a familiar trick of geometry. Think of the surface of Earth. If you are standing in a field, the ground around you feels flat enough to trust. You can walk in a straight line. You can put down a cup of coffee without worrying about gravitational drama. On small scales, the curvature of the planet hides itself. But Earth as a whole is not flat. It curves back on itself. You can keep traveling without ever finding a border where the surface simply ends. There is no giant seam in the Pacific labeled end of planet. Thank you for visiting. There is only a continuous surface. That gives you a very comforting model for the universe. Something can be finite in a certain sense and still have no edge. It can curve. It can close back on itself. It can be complete without being bordered. The surface of Earth is only a two-dimensional example, of course, while the universe involves three dimensions of space, which is where your imagination begins to politely request a nap. But the principle still helps. A three-dimensional space can, in theory, have a geometry that is finite yet unbounded. You could travel through it indefinitely and never encounter a wall, because there would be no wall to encounter. Space would simply be structured in a way that does not require one. That possibility is one reason cosmologists are careful with the word edge. If the universe is curved in the right way, there may be no meaningful edge at all. Not hidden, not distant, simply absent. There are a few broad possibilities people consider when talking about the large-scale geometry of the universe. Space can be positively curved, roughly like a higher-dimensional analog of a sphere. It can be flat on large scales, or it can be negatively curved, more like a saddle shape, though that image only goes so far before the analogies start behaving mischievously. Each option affects how light travels across great distances, how parallel lines behave, how the angles of enormous cosmic triangles add up, and how the universe as a whole might be arranged. The fascinating part is that modern observations suggest the universe is very close to flat, at least on the scales we can measure. Measurements of the cosmic microwave background and other large-scale data indicate that if space does curve overall, it does so gently that the curvature is extremely hard to detect. From your local point of view, and even across vast observed distances, the cosmos appears remarkably flat, which is almost comically understated for something so enormous. Flat, though, does not automatically mean infinite in the simplest naive sense, and it does not automatically settle the question of topology, which is the more subtle issue of how space may be connected. Geometry tells you about local curvature. Topology asks deeper questions about global structure. Two spaces can be locally similar, and yet globally arranged in very different ways. That sounds technical until you soften it into an image. Imagine an old video game where a character walks off one side of the screen and reappears on the other. Locally, the world looks ordinary. You move in straight lines. Nothing seems strange right around you, but the larger arrangement of the space has a hidden connection. I am not saying the universe is literally a vintage arcade level, though that would explain a few things. The point is that space can be more subtly organized than everyday intuition expects. So when you ask whether the universe has an edge, you are really asking several layered questions at once. Is space finite or infinite? Is it curved or flat? Is it connected in a way that closes back on itself? Is the observable part only a tiny patch of something much larger? Your mind comes looking for one clean border, and the universe hands you geometry, topology, expansion, horizons, and the kind of polite complexity that never raises its voice. There is something deeply calming in that complexity because it removes the idea of a final drop-off. The cosmos is not a platform suspended over nothing. It is a structure, possibly endless, possibly finite in some elegant closed way, but not the kind of thing that needs a last brick at the outer wall. Even if the universe is infinite, that does not mean it stretches like an endless hallway with fluorescent lights humming overhead forever, which would be a deeply unfortunate aesthetic choice. Infinite space, if that is what reality has chosen, simply means there may be no overall boundary and no final extent. More galaxies, more structure, more regions beyond regions without a master perimeter. And if the universe is finite but unbounded, that is somehow just as soothing. You still do not crash into an edge. You move through a complete spatial fabric, that does not end the way objects in your room end. One of the quiet joys of modern cosmology is that it allows both wonder and restraint. Scientists do not claim more than the evidence can support. The observable universe is measurable in many ways. The full universe beyond that remains partly hidden. The large-scale geometry appears very nearly flat. The global shape is still not known with complete certainty. That uncertainty is not a flaw in the story. It is part of the beauty of it. Science is allowed to say, very softly, "This is what we can tell," and beyond that the dark remains patient. And the dark is patient. You can imagine yourself far beyond the Milky Way for a moment, beyond local clusters, beyond the grand filaments where galaxies gather like dew on invisible threads, simply floating in thought across scales too large to hold, and still there is no sign of a cosmic cliff, no hard shell, no outside window where you can peek at whatever lies beyond reality's drywall. The farther you stretch the idea, the less an edge makes sense. What begins to make sense instead is consistency. Space behaving according to its own geometry, light following that geometry, matter gathering within it, expansion unfolding through it, the whole universe acting less like a built container and more like a self-contained order. Remember the Earth analogy again, but keep it gentle. Ancient people could stand on the ground and ask where it ends, because that is what creatures on surfaces do. The answer turned out not to be a sharp end but a larger shape than immediate experience revealed. In a similar way, you stand inside the visible cosmos and ask where everything ends. The answer may be not a border but a larger geometry than human instinct first imagines. That shift can make you feel wonderfully small in the safest possible way. You do not need the universe to have a clean edge to live meaningfully inside it. You do not need the final blueprint. You are already held within the structure whether or not you can map the whole of it. The stars still shine. The background glow still surrounds you. The laws of light and gravity still guide the deep arrangement of things. Mystery does not remove belonging. And once shape replaces edge, another beautiful question arrives almost on its own. If the universe looks so smooth and flat and evenly spread on enormous scales, how did it become that way in the first place? Why is the cosmos so strikingly uniform across regions that seem far too distant to have calmly coordinated with one another? There is an idea for that too, ancient in its timing and startling in its scale. And it begins in the earliest moments with a burst of growth so swift that even this expansive universe still carries its signature. That signature begins so early that even calling it the beginning feels a little clumsy, because the first moments of the universe are not arranged in a friendly way for ordinary language. Still, there is a beautiful idea that helps explain why the cosmos looks so smooth across enormous distances, why the oldest light is so even, why space seems so close to flat, and why the large-scale universe carries this remarkable feeling of calm order. That idea is cosmic inflation, and despite the dramatic name, it leads to one of the most soothing pictures in all of cosmology. Inflation refers to a brief episode in the very early universe when space expanded at an extraordinary rate. Not ordinary expansion stretched over billions of years, but a tiny fraction of a second in which the scale of the universe grew enormously. It is one of those facts that can sound loud on paper and still feel strangely elegant when you sit with it. The young cosmos, in one unbelievably brief interval, seems to have undergone a tremendous swelling, smoothing and flattening as it grew. You can think of it as a tiny patch becoming immense before it had time to become complicated. That image helps because it explains something that might otherwise feel odd. When you look at the cosmic microwave background, the sky appears almost the same in every direction. The temperature differences are incredibly small. That near uniformity is one of the most striking facts about the observable universe. Regions of the sky separated by enormous distances look as though they somehow share a common history. Even though under ordinary expansion alone, they seem too far apart to have exchanged enough information or energy to become so well matched. Inflation offers a quiet solution. Before the great stretching, the part of the universe that became your observable cosmos may have been much smaller, small enough for conditions to settle into remarkable uniformity. Then inflation expanded that smooth little patch to enormous size. So when you look across the sky and see the same general afterglow in every direction, you may be seeing the enlarged memory of an earlier closeness. That is a very comforting thought. The vast calmness of the observable universe may come from the fact that it was once intimate. It also helps explain why space appears so close to flat. A curved surface can look flatter and flatter the more you enlarge a tiny portion of it. If you stand on Earth, the ground under your feet seems level, even though the planet as a whole is curved. In a similar spirit, inflation would have stretched the geometry of space so greatly that any large-scale curvature became extremely subtle within the part you can observe. The result is a cosmos that, to the best measurements available, looks very nearly flat. Again, the mood here is not violence. It is smoothing, broadening, simplifying. Inflation takes a young and tiny region and spreads it into something graceful and huge, the way a small wrinkle can disappear when fabric is drawn taut. That does not tell you everything about the full universe, and cosmologists still debate the deeper details of how inflation worked or what precisely drove it, but it does give a strikingly good account of several major features the universe actually seems to have. And perhaps the most gentle part of all is this. Inflation may also have taken tiny quantum fluctuations, minute little irregularities in the early universe, and stretched them across cosmic scales. Those fluctuations were not dramatic bumps or cosmic tantrums. They were tiny variations, small differences in energy and density at the earliest times. But once inflation magnified them, they became the faint seeds that later allowed gravity to build structure. Over immense ages, those little imprints helped shape the galaxy clusters, filaments, and vast patterns that fill the observable universe today. So once again, the grandest architecture grows from something almost delicate. The largest structures in the cosmos may trace their ancestry to faint early whispers, stretched wide by inflation, and then patiently refined by gravity. You keep finding the same quiet theme at every scale, complexity rising from softness, immensity growing out of something barely uneven at all. There is a kind of emotional relief in that pattern. It means the universe does not need constant drama to produce magnificence. It can begin with subtlety and still arrive at galaxies. Of course, inflation remains part of active science, not a bedtime fairy tale dressed up in technical language. It is strongly supported by several lines of evidence, especially the large-scale smoothness and flatness of the observable universe and the character of the tiny fluctuations seen in the cosmic microwave background. But some details remain open. Researchers still ask what field or mechanism caused inflation, how exactly it started, how it ended, and whether it links to even deeper layers of physics not yet fully understood. That uncertainty is handled gently in cosmology because the evidence points towards something inflation-like, while the full story remains slightly beyond reach. That balance between clarity and mystery is one of the nicest things about this subject. The universe gives you enough to trace the shape of the answer, but not always enough to close the case with a smug little snap. There are even more expansive ideas growing out of inflation, including versions where inflation may continue in other regions, producing an enormous larger cosmos with different pockets or domains. These ideas live at the more speculative edge of cosmology, and it is good to treat them with a calm, careful hand. They are not established in the same direct way as the existence of the cosmic microwave background or the redshift of galaxies. Still, they arise naturally from some inflationary models, and they keep alive the possibility that your observable universe is only one calm window inside something vastly bigger and more varied. You do not need to decide all of that tonight. It is enough to notice the feeling it creates. The universe may be far larger than what you can see, and the portion you do see may owe its smoothness to an ancient, breathtaking expansion that happened before stars, before galaxies, before the oldest light had even fully begun its long, open journey. And yet the evidence of that event may still be with you, written gently into the sky. That is the part that feels almost impossible in the most restful way. You can stand on a small planet around an ordinary star in one spiral arm of one galaxy and still read traces of an event that may have happened in the universe's earliest fraction of a second. Not directly, not with naked eyes, not with total certainty about every detail, but with enough evidence to make the cosmos feel legible. The night sky is not just beautiful, it is informative. It remembers. Remember that word because it matters soon. The universe remembers through light, through pattern, through structure, through the way expansion has shaped what reaches you and what does not. The edge you were searching for has already turned out to be a horizon, a glow, a geometry, and an ancient stretching of space itself. And from here, the final mystery becomes even calmer. Beyond the horizon, beyond the oldest light, beyond the reach of all future observation, there may still be more universe resting in silence, not absent, not imaginary, simply outside the circle of what can ever be shown. Outside the circle of what can ever be shown. That may be the quietest phrase in this whole journey, because it asks you to imagine something without demanding that you conquer it. The universe may extend beyond your horizon in ways that no telescope, no future observatory, no brilliantly stubborn civilization can directly uncover through light alone. And still, this does not feel like a failure of science. It feels more like standing at the edge of a foggy coastline at dawn, knowing the sea continues past what your eyes can trace, even when the line between seen and unseen has gone beautifully soft. By this point, the idea of an edge has changed shape several times in your mind. It began as a possible border, then it became a horizon, then an afterglow, then geometry, then expansion, then a deeper kind of limit created by accelerated distance, and after all of that, you arrive at one of the gentlest truths in astronomy. There may be parts of the universe that are real in every physical sense, and yet permanently unavailable to observation from where you are. That is not because science gives up. It is because science is honest. There is something deeply calming in that honesty. The best cosmology does not pound the table and pretend certainty where certainty has not been earned. It reads the sky carefully. It notices patterns. It builds models that explain what can be measured. And when the measurable world reaches its horizon, science does something quietly admirable. It says this is as far as the light lets us go. You can rest inside that. Because once you accept that some things lie beyond the horizon, mystery changes character. It stops feeling like a threat and starts feeling like open space. A reminder that reality is larger than access, larger than evidence in hand, larger than the illuminated patch available to one species on one small world during one very specific cosmic era. And you have lived with that kind of truth before, just on gentler scales. You have stood in a dark field and known there were trees beyond the line of sight. You have watched the ocean disappear into night and never taken that darkness as proof the water had ended. You have listened to voices through a wall and understood that unseen things can still be entirely real. Cosmology extends that same humility across distances, so vast they begin to feel more like mood than measurement. Beyond the observable universe, there may be more of the same large-scale cosmic structure. More galaxies, more clusters, more stretches of dark matter guiding the architecture of space, more ancient light still traveling within regions forever disconnected from your own. Or, if some of the more speculative ideas born from inflation hold true, the larger cosmos may be stranger still. There could be regions with different histories, different large-scale conditions, perhaps even different effective physical features. Those ideas remain uncertain and are treated carefully, as they should be. But even the most conservative picture already gives you enough wonder to work with. There is likely more universe beyond what you can see. And that more does not need to be described in sharp detail to feel magnificent. Sometimes the most relaxing thing is not definition. It is permission. Permission to let the unknown remain beautifully shaped but unfinished. Permission to stop forcing a border where reality may offer only continuity. Permission to let the darkness beyond the horizon stay dark without turning it into fear. The night sky encourages that kind of thinking because it is full of evidence that truth often arrives partially. You never get the whole universe at once. You get photons. You get faint spectra. You get redshifts, tiny temperature differences in a microwave afterglow. The subtle wobble of gravity in places where visible matter alone cannot explain what is happening. Small clues calmly received. The cosmos rarely shouts its deepest secrets. It leaves them lying around like polished stones. That style of revelation is worth noticing. It means mystery and knowledge are not opposites out here. They cooperate. Mystery keeps the horizon open. Knowledge teaches you how to read what little light has crossed it. This is one reason the edge of the universe can become such a strangely comforting subject. You start by looking for a final line, and instead you find a philosophy of limits. You discover that some boundaries are not walls but conditions, not endings, but relationships between time, motion, light, and space. The observable universe tells you what can currently be seen. Cosmic expansion tells you what can still arrive. The microwave background tells you how far back ordinary light can take you. Geometry tells you an edge may not even be the right category. Every answer reduces a little fear and adds a little elegance. And elegance matters more than people admit. A universe with a literal jagged outer edge would almost feel cruder than the one you actually inhabit. The real cosmos is subtler. It lets visibility fade into theory. It lets evidence meet imagination without being swallowed by it. It allows the unknown to remain disciplined. You are invited to wonder, but not to invent wildly just because the darkness is roomy. That balance is beautiful. It keeps the mind awake without making it tense. You can almost feel the difference in your body when you think about it slowly. A hard edge would make the universe seem boxed in, mechanical, almost crowded. A horizon makes it feel spacious. A larger unseen beyond that horizon makes it feel generous. Reality is not a sealed room. It is a widening quiet. There is another lovely consequence here too. Because every observer occupies the center of their own observable patch, no one gets to hold the whole visible story. Every civilization, if others exist, would inherit a local version of the cosmic view. Their horizon would be different in detail, centered elsewhere, shaped by their own place in the unfolding fabric. That means knowledge itself is local before it becomes shared. Everyone begins from one window. No one begins from the roof. That is a humbling thought, though a very soft one. Your perspective is real and valuable, but not complete. The same is true for any mind anywhere. The universe is not arranged to flatter the observer with total access. It offers partial views and invites patience. Perhaps that is why the greatest discoveries in cosmology often feel less like triumph and more like deepening stillness. You learn that the stars are suns, that galaxies are vast cities of stars, that the universe expands, that ancient radiation still fills the sky, that most matter is dark, that expansion accelerates. Each fact enlarges the room. Each one makes human certainty sit a little farther back and lower its voice. And lowering the voice is good here. Because beyond the horizon, whatever exists does not demand immediate resolution. It is enough to know there may be more. Enough to know that unseen does not mean unreal. Enough to know that science, at its most graceful, can walk you right up to the border of observation and then stop with dignity, leaving the silence intact. Remember that silence because it matters very soon. The final step in this journey is not to solve the universe or reach its edge, but to understand what the search itself has given you. Not a wall, not an ending, something much calmer, a way of living under a night sky that feels larger, stranger, and somehow kinder than it did when you first looked up. What the search has given you is something quieter than an answer and far more useful than a border. You began with the simple human instinct to ask where the universe ends, and the farther you went, the more that question softened into something deeper and more beautiful. The edge never appeared as a wall or a cliff or a final painted line in the dark. It kept becoming something gentler, a horizon of visibility, a glow from the early universe, a geometry too large to hold all at once. A limit created by time, by light, by expansion, by the patient rules that shape what can and cannot reach you. And in the end, the most relaxing fact about the edge of the universe may be that it does not feel like an ending at all. It feels like openness. It feels like reality refusing to become small just to satisfy the habits of the human mind. That is strangely comforting. You spend so much of life inside containers, rooms, schedules, screens, roads, calendars, deadlines, names for things, endings for things, beginnings for things. Even your thoughts like to organize themselves into edges and categories because edges feel manageable. They tell you where one thing stops and another begins. But the universe has been quietly offering a different lesson this whole time. Not everything needs a hard boundary to be real. Not everything meaningful ends with a visible seam. When you look up into the night sky, you are looking into a place where the deepest limits are soft. Light arrives late, space expands. The oldest visible glow surrounds you from every direction. Galaxies slip away so gradually that their retreat can only be known through patient measurement. Even the unseen beyond the horizon is not presented as a threat. It is simply more that cannot yet be reached, more that may never be reached, more that does not need to become yours in order to exist. That idea can settle the mind in a very particular way. It replaces the urge to conquer with the ability to accompany. You do not need to master the edge of the universe. You only need to sit beside it for a while and notice what kind of truth it offers. And the truth it offers is slow. Everything important out there happens with a kind of enormous patience. Light crossing billions of years, gravity gathering faint differences into galaxies, ancient radiation cooling into a microwave whisper, space widening between distant regions without any sound at all. If the universe has a personality, it seems to prefer quiet persistence over spectacle. Even its grandest facts arrive gently when you really let them in. You can feel that gentleness most clearly when you return in your mind to the oldest light. That faint background glow is still one of the most moving things in science. The sky does not just contain stars and darkness. It contains memory. A relic from a young universe still rests all around you, stretched and cooled but not erased. Reality remembers its beginning softly. It does not cling to it in a loud way. It keeps it as a background warmth, almost gone, still present, like the last trace of heat in a room after the fire has settled down. And then there are the galaxies, each one a long-form answer to the question of what time can do when left alone with matter and gravity. Islands of stars, turning in the dark, each holding more suns than the mind enjoys counting, each separated from the next by gulfs so wide that even light has to devote ages to crossing them. The universe is not crowded. It is spacious in the deepest possible sense, not empty in a disappointing way, spacious in a graceful way, spacious enough for history to travel, spacious enough for silence to matter. That may be why thoughts of the cosmos can calm you when smaller thoughts cannot. The universe does not remove your ordinary life, but it changes the scale around it. A worry that fills a room does not fill 93 billion light years. A restless evening does not disturb the cosmic microwave background. A hard day on Earth remains real, but it no longer claims to be the measure of all things. The sky offers proportion without cruelty. It does not mock your smallness. It simply places it somewhere honest. And honesty is soothing. The honest answer to where the universe ends is not a single sentence. It is a calm collection of understandings. The observable universe has a horizon because light has a speed, and the cosmos has a history. Beyond that horizon there may be vastly more universe. Space itself expands, which changes how distance behaves and how old light arrives. The oldest light you can directly observe comes from a young universe becoming transparent. The large-scale geometry of space appears very nearly flat, though the full global shape remains uncertain. Some distant regions may never be able to send you their future light. The edge, in every practical sense, becomes less like a border and more like a relationship between you and the deep structure of reality. And perhaps the most beautiful part is that these facts do not make the universe colder. They make it more intimate. That may sound backwards at first. How could something so huge become intimate? Yet it does, because all of this reaches you through light, through measurable whispers, through ancient signals arriving in the present. You are not cut off from the cosmos. You are in conversation with it, though the conversation takes place on timescales so leisurely that entire civilizations fit between one sentence and the next. The stars speak in photons. The background glow speaks in faint microwaves. Redshift speaks in stretched wavelengths. Gravity speaks through motion and structure. The universe is not silent. It is simply speaking very, very slowly. And you, on this small turning planet, have learned enough to hear some of it. That is not a trivial thing. It is one of the loveliest achievements of the human mind. A species that evolved under weather and moonlight and hunger and sleep eventually learned to measure the afterglow of the early universe. Learned to notice that galaxies are receding. Learned to infer dark matter from gravitational behavior and dark energy from cosmic expansion. Learned that looking far away means looking back in time. Learned that the edge of the visible universe is a horizon, not a wall. There is a quiet nobility in that. Not because humanity has solved everything, very far from it, but because it has learned to ask the right kind of patient questions. You can carry that patience back down into your own life. You can let the universe teach you that some things become clearer only when given time. That not every unknown needs to become immediate knowledge. That some horizons are natural and not personal. That distance is not hostility. That mystery can be part of beauty rather than a failure of understanding. Even the possibility that there is no final visible edge in the ordinary sense has a restful quality to it. You do not live in a cramped, sealed box. You live in a cosmos that may be larger than any map, older than any story told on Earth, richer than any single observer can witness, and still readable enough that a few gentle truths can make their way into your room at night, into your headphones, into the quiet place in your mind that recognizes scale and becomes softer because of it. Remember the porchlight feeling from the beginning. One person under one sky looking up. That is still where this ends, if it ends anywhere. not at a boundary in deep space, but in a renewed way of seeing from home. The night above you is no longer only dark. It is full of delayed arrivals, ancient warmth, widening distance, hidden structure, and horizons that do not threaten you. The universe does not seem to hurry toward a conclusion. It simply keeps unfolding, and for one brief human life you get to notice. You get to stand inside a visible patch of the cosmos while old light continues to arrive. You get to live in an era when the sky still reveals its expansion. You get to know that what you see is not all there is, and that this does not diminish the beauty of what is visible. It increases it. Every star becomes part of a larger unseen context. Every dark gap becomes less empty and more patient. Every limit becomes a reminder that reality extends beyond access. That is enough, more than enough really. So when you think of the edge of the universe after tonight, perhaps you will not picture a final line at all. Perhaps you will picture a quiet horizon made of time, a faint glow left over from the first visible dawn, galaxies receding through expanding space, a cosmos that may go on far beyond what can ever be seen, holding its further distances without the slightest need to explain itself all at once. And perhaps the most restful part of all is this: you do not need the final answer in order to belong inside the mystery. You already do. The sky was never asking you to solve it completely. It was only asking you to look up long enough for your thoughts to grow wider and your breathing to grow calmer and your little human sense of enclosure to loosen. The edge of the universe, once you meet it properly, does not trap the mind. It opens it, quietly, almost politely, as if the cosmos has no interest in rushing and no objection to letting you rest inside its unfinished grandeur for as long as you need. For a moment longer, you can leave the measurements where they are. Leave the galaxies to their patient drifting. Leave the ancient light spread across the sky like a memory too large to hold directly. Leave the unseen beyond the horizon resting where it has always rested, outside the circle of visibility, but never outside reality. Let all of it remain vast. Let all of it remain gentle. And let yourself be small in the safest possible way. The planet beneath you turns without asking anything more of the night. The stars keep their distances. The old photons keep arriving. The universe remains immense, structured, unfinished, and calm. There is no final wall pressing inward. There is only depth, and the soft knowledge that what you can see has always been enough to fill a lifetime with wonder. The world can shrink again tomorrow if it needs to. Emails and errands and clocks are very committed to their craft. But tonight, you have spent a little while with something larger than all of that, and larger in a way that does not demand performance. Larger in a way that makes room for quiet. Larger in a way that lets your thoughts settle like dust in still air. So keep the image that feels best to you. The curved earth under a dark sky. The ancient background glow filling all directions. The observable universe like a horizon around every observer. The galaxies drawing away through expanding space. The possibility of more beyond all sight. Keep whichever one rests most softly in your mind and let it stay there without effort. Because the universe has no interest in rushing. It will still be there, wide and patient after this thought, after this night, after 1,000 more quiet nights. And you have already seen enough. For now, let the scale grow gentle again. Let the distances blur into softness. Let the old light fade into a low silver hush somewhere beyond the rooflines, beyond the clouds, beyond the thin blue veil of air that keeps your world warm and close. Let the galaxies lose their names and become only scattered calm. Let the cosmic background rest like a hidden warmth behind the dark. Let the horizon of the observable universe dissolve into something less like a boundary and more like a tender circle of knowing, a lantern of visibility floating inside a much larger silence. You do not need to follow it farther. You can stay here, on this small, steady world, with your breathing easy and your thoughts unknotted, held by the simple fact that the universe is vast without being cruel, mysterious without being hostile, distant without being empty. Its edges, if that word even still applies, have become soft enough to rest against. Its oldest light has crossed all this way only to arrive quietly, and perhaps that is the final lesson worth keeping. The deepest truths do not always burst in. Sometimes they travel for billions of years and enter the mind as a whisper. So the sky can grow dimmer in your imagination now. The measurements can loosen. The questions can curl up beside the answers and sleep there together. Above you, beyond you, all around you, the cosmos keeps its patient order. Nothing needs to be finished tonight. Nothing needs to be chased. The stars remain where they are. The horizon remains where it must. The unseen remains real. And you, for this small, peaceful moment, are safe beneath it all.